Hi, hello sixth graders. We have a video today on creating a box and whisker plot. I know yesterday's vocabulary assignment with box and whisker plots moved pretty quickly, so I'm going to break it down for you today by just creating one, and I feel like it'll help make it a lot more sense out of it. And I'll even give you at the end of the video a few examples of where this would be really useful, all right, in comparing some data and especially the variability of a data set. So a box and whisker plot is something that represents the data along a number line by using a whole bunch of different parts: the least value, the greatest value, and then the quartiles of the data. Now you might be thinking, what the heck's a quartile, right? Well, if you look at the word quart, you're thinking it's going to have four pieces, right? Four parts. So it's breaking our data up into quarters, and here's another way to think about it, is that about a quarter of the data is in each one of the whiskers. That's the strings that we're making off to the edge of the box. And about half of the data is in the box, with, again, the second quarter broken up between the edge of the box and the median, or our middle part of our data, and then another quarter broken up between the median and that third quartile. So, again, those are the pieces of it. You have the box in the middle, which has about half the data, the whiskers that each have a quarter off the end, and we're also going to mark, again, that median right in the middle of the box. And so I have picked a problem to do an example with here today. I had originally, this data is just kind of out of context, but I chose this data because it has some key parts that'll help us when we're describing the median, and the numbers are pretty easy to work with here. So it says create a 5-number summary, a box and whisker plot, to draw for this set of data. Now, the big habit that I always try to get students to do anytime we're working with data like this, whether we're doing mean, median, mode, or range, or mean absolute deviation, or here today with our box and whisker plot, is count your data values right away. So I'm going to just count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know I'm working with 10 values. That's going to be important in a couple of different times, especially if I'm making a mean, or if I'm calculating mean, I need to know what to divide by. But in this case, I need to know how many data values I'm working with when I'm finding the median. Is it going to be the number smack dab in the middle, or is it going to be an average of the two numbers in the middle? And I want to make sure I have all my data accounted for when I order them from least to greatest. So I'm going to just make this list real quick. And then I'm going to recount my list at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's how I make sure that I have all my data values accounted for. Now to find the median, we're just going to start taking numbers off the top and bottom, because the median is the value in the middle when they're listed from least to greatest. But of course, here's where I come into a problem. Because I have an even number of data values, 10 values, there is not a number in the middle. You understand, if I had 9 values, I'd take 4 off the bottom and 4 off the top, and there'd be 1 left in the middle, and it'd be perfect for finding my median. But because there's an even number of data values, whether you had 10 values or 12 values or 20 values, there's going to be 2 numbers in the middle when you take the same number of values off the top and bottom of your list. So now I need to calculate the average of those 2 numbers. And remember, average or mean would be to add them together, 8 plus 10, which is 18, and then divide it by 2. So 18 divided by 2 is 9. So finding the median is 9. And to explain how I found this value, in this case, I found the mean of the 2 values in the middle, because, again, there was an even number of data values. If there were an odd number of data values to find the median, I would just say I listed them in order from least to greatest and found the number in the middle. Another way, I know some of you are looking at this thinking it's just going to be the number right in between those. Yes, that's another way of thinking of the mean of 2 numbers, but it won't always be so obvious as it is right now with 8 and 10 in the middle. Now, it says the lower quartile, again, it might be a new word to some of us here, is the median of the lower half of the score. So even though this word sounds kind of cool, and we're going to talk about things like interquartile range down here, they're not that difficult of concepts. The lower quartile is the median of the lower half of scores. So let's just draw a line between the upper and lower half of my scores, and I'm just going to relist these numbers on the lower half. 3, 3, there's 4, 7, 8. And now it says we need to find the median of those. Well, that one, it is now an odd list because there's only 5. So now I find the number in the middle. So my lower quartile is 4. What is the lower quartile of the data? 4. Do the same thing for the upper quartile. 10, 11, 12, 13, 18. So I took that upper half of the data, and now I'm going to do the same thing here and find the value in the middle. Upper quartile is 12. So it says, what is the interquartile range? That's the difference between the upper and lower quartile. So difference tells me I'm subtracting. Run out of room here. Okay. Difference, I'm going to do 12 minus 4, which is 8. And so what that interquartile range is telling me is that half of my data, again, if we remember back to this guy here, half of my data is going to be in this range of 8, from 4 to 12. Now this one doesn't have any numbers, but we're gonna make one right now, and you'll see how that plays out on here. Actually, let's straighten this back out. If I do this, there we go. So it says draw a number line and create a box and whisker plot. This 5-number summary. Okay, so I already drew the number line, and now all we're going to do is take these numbers, these pieces that make up your box and whisker plot, and we're going to place them all in there. I'm just going to put a dot for each one of them to start. The lower extreme, the lowest value we have, the lower quartile, the median of the lower half, the median of all the data, the upper quartile, or median of the upper half of data, and then the upper extreme, or the highest number that we have. So if we look, and we just found all those, right? So if we look at those 5 numbers, the lowest number on our list was a 3. I'm just going to place a dot above 3. The lower quartile was 4. So we have a real short whisker on this box and whisker plot. The median was 12. And the upper quartile was 12. The median was 9. We gotta go all the way back up here. I apologize, but we still had a dot there. So the median was 9, and the upper quartile was 12, and then the highest value on our list was 18. Okay. Then I'm just gonna get out my ruler. Oh, actually, before that, I'm just going to draw a vertical line through that upper quartile, through that median, and through that, the lower quartile, the upper quartile, the lower quartile, the median, and the upper quartile. And now I'm going to connect those dots using a ruler. We'll connect those lines. And that creates my box. Okay, and then I'll connect that whisker by just connecting that dot on each end, the lower and upper extremes. I'll connect them to the box. And we end up with something like this. Now what a box and whisker plot tells us, and I mentioned I'd give you some examples of where it might be useful, is it tells us how spread out the data is, okay, or where a lot of the data is grouped. So the whisker on the right side in this is a lot longer than the whisker on the left side. So again, this data was taken out of context, but the data is typically going to be grouped tighter together here. There's a lot of, remember, there's as many data values in here, in this whisker on the left, as there are in this whisker on the right. So it's a lot more compacted here and a lot more spread out over here. So where could this be helpful. Again, we could look at the shape of that data, and we could talk about it being skewed one way or the other. That's not, where is most of the data, like I was just kind of saying. But where you might see it is, again, in a comparison. This is something called a double box and whisker plot. And you can see, like, here's the age of crocodiles and alligators. Here's another one if you were comparing the prices of snowboards, something like that. Like, in this case, store B obviously has a lot more expensive snowboards, are generally higher and that type of thing. But here's probably one of the better ways to show how it could be useful. This one will probably make sense to a lot of us. We have Team 1, a very balanced scoring here, and Team 2, this is, what does it say, soccer? Looks like soccer, goals scored per game. Oh, lacrosse, sorry, in a 16-game season. So if you just ask these questions here, I think box and whisker plot makes a lot of sense. Like, which team is more consistent? Well, looking at this, the team that's more balanced, right? They have a shorter box and whisker plot to begin with, Team 1, and the number of goals they scored in all those games were much more spread out than Team 2. With it being really compact on this end, it looks like, again, this represents a quarter of the data and a quarter of the data. So in half of their games, they scored this many goals from here to here. A quarter of their games, a quarter of their games, and now a quarter of their games and a quarter of their games. So not very consistent compared to this one. Very consistent, quarter of their games, quarter of the games, almost all the same size, right? If they said, and then this question is a great question, if Team 1 and Team 2 played once during the season, based on the data provided, which team do you think won? Well, Team 2 scored 18 goals. Oh, man, that's a lot of goals. Do you think they could beat Team 1? Yeah. Like, look at, if Team 1 scored 8, they scored 18. Or if Team 1 scored 10, there could have been a game where Team 2 scored 16 or something. We don't know the individual goals scored in a game. But over time, okay, there were very few instances that Team 2 scored that high, and Team 1 was very consistently higher than Team 2. For half of the games, remember this is a quarter of the games and this is a quarter of the games, Team 2 didn't even score as many as the lowest game of Team 1. So in over half of the games, it would have been easy to expect Team 1 to score more than Team 2. All right, so a very, I think, clear example of where you could use it for a comparison, a point of comparison when you have a double box and whisker plot. So for today, what I have is I've shared this original box and whisker plot that I created. I'll share that example with you as well, so you have a little bit of notes on the topic. And then you're going to be back into Freckle and ST Math today. And Freckle, we should be getting into box and whisker plots and starting to work with them in your homework as well. If you want to go back into vocabulary and take another look, now that you've seen me explain how to create a box and whisker plot, you could always try some of the question banks or the Build-A-Beat again in vocabulary as well. We'll be back tomorrow starting to look at mean absolute deviation. Have a great rest of your day.